Let's see, non-uniform jackets. Matthew, do you? Yeah, and then Becky. Let's see. All right, so there's two things going on, being passed on, two worksheets. We'll go through both of them. And do I have your labs from yesterday turned in? So let's go through the single page worksheet to start with. So it says, it starts at number 5. It says that a bullet leaves the barrel of a gun 925 meters per second at an angle of 5 degrees. What are the bullet's vertical and horizontal velocity components? So in order to find these, so the vertical velocity, you would take the magnitude, 925 meters per second, and multiply it by what to get the vertical velocity? Yeah. That would be if you had acceleration, right? If you're looking at, if you were to use that. But in this situation, you want to use sine or cosine. Which one would give you a vertical, sine or cosine? Cosine would give you, yeah, that's right. So we would, all we need to do is take 925 and multiply it by sine of 5 degrees in order to get the vertical component. Make sure that you all are in degrees for these problems. Yes. Yeah, sure, yeah. 80.6, good. So 80.6, it got the right number of sig figs too, good. So it got 3 sig figs, so we need 80.6. Okay, and then horizontal, we would need to do 925 times cosine. Okay, almost. Now with sig figs, what do we do with sig figs? 925? 921, good. Yeah, 921. All right, so that's all you do for that. The others are similar, so I'll let you do the other ones. Let's go on to the next one. I want to go through a few things in that packet. Then after I've gone through a few things for the next one, you can then do the rest on your own. So all the ones on that single page do the same way. For the other packet that is 3 pages, let's go through the first part. So for number 1, actually before number 1, there's something that goes above number 1. Just right below the name, it says, to solve projectile problems, you must divide your information into 2 parts. Horizontal, which has uniform motion, and vertical, which has accelerated motion. So just go and fill it in because we didn't go through in the book, but you need to know that for this packet. So you need to divide into 2 parts. Horizontal, which has uniform motion, in vertical, which has accelerated motion. So what does that mean? Well, anything in the air, let's say you look at a ball going off the table. There's two parts to that ball's motion. It has a downward movement and a forward movement. So it has both vertical and horizontal acceleration. Gravity pulls it down, gravity exerts a force. So when there's a force exerted, things accelerate. But is there a force making it go forward? Is there a force on the ball that makes it go forward? Yeah, right. Yeah, just the ball roll off the table, just nothing else besides the ball off the table. Is there any force moving it forward? No. So because there's no force moving it forward, there's no acceleration. The ball just stays the same speed. We're ignoring air resistance because in reality, air resistance does slow down a little bit, but ignoring air resistance, the ball goes the same speed horizontally the whole time. It doesn't change. So if it leaves the table with a speed of 5 miles per hour, that's horizontal, that would be constant throughout its journey. That does not change. Now, if it's really windy or if it's going fast, then the air will slow it down. But ignoring air resistance, it would be constant. I mean, really, if it's a heavy object going at a moderate speed, it's going to stay pretty much the same speed through the air. If it's very windy or if it's going really, really fast, then it would slow down a lot. So in most cases where it's not very, like in this room, for example, throwing like a, say a golf ball, it would maintain its speed pretty well through the air. But you throw, say throw a fastball, like a baseball going 100 miles per hour, you are going to see a drop off in speed going that fast. Okay, so that means that there's no acceleration. Acceleration is 0. In the horizontal dimension, acceleration is 0. There's no change in speed horizontally. That's not the case vertically, though. So vertical, what happens? Well, the ball off the table originally has no vertical speed. It's not going upward, it's not going downward at first. So initially, so in the vertical component, there is no initial speed. Now, if you threw it at an angle, then that would be different. If you threw it, say, like this, well, now there is initial vertical speed. It's going upward, you threw it upward. But if you're dropping something, like in this case, it rolls off the table, at the very beginning, it's not going upward or downward. So there's no vertical speed initially, but over time, it does accelerate downward. So no initial vertical speed, but it does accelerate. So it accelerates at 9.8 meters per second squared. So that's true at any time it's in the air. Acceleration is always 0 horizontally. It's always 9.8 vertically. And if it's dropped, then it always starts at 0 speed vertically. Does that make sense for everybody? So using that information, we're going to solve some problems in this worksheet. Let's go through number 1 together. So it says for number 1 that a ball rolls off the table. So the table is 1 meter high. And it says the ball lands 3 meters away from the table. How long is the ball in the air? So we're solving for time here. It helps in this situation to think about what are the y components, what are the vertical components, what are the horizontal components. So I think of it in terms of x and y. So you have the x components, which are the vertical component and horizontal components, and the y components. So we've said before that in the x dimension, acceleration is 0. That's always true. Anytime it's in the air, acceleration horizontally is always 0. Then for the y dimension, it's always 9.8. Actually, we should say negative 9.8. It always goes downward. So this is always true, no matter what the situation is. If it's in the air, this is always true. Also, it starts off the table with no initial vertical velocity. It's not going upward, not going downward. So in the y dimension, initial velocity is 0. So that's always true if you're dropping something, if it's going off the table, or if you're throwing in a straight line. Then there's no initial vertical velocity, that's 0. What else do we know? Initial horizontal velocity is not known in the x dimension. It's going forward at a certain speed, but we don't know, we weren't told what that was, so we don't know that one. Distance. What is the y distance? 3 meters. So x would be this way, right? Y would be that way. Yeah, good. So 1 meter upward would be the y. Now it's moving downward, right? So we would say -1 because it's a downward movement of 1 meter. And then the x distance, 3. So that's all the things that we know. If we know 3 things in a dimension, we can solve in that dimension. So we know 3 things in the y dimension, we can solve in that dimension. What are we looking for? We're looking for time. So there's 3 equations that we can make use of. And these ones you should have written down in your note card, but just in case, you need to use these ones. So one you'll use is VF, the final velocity squared, equals initial velocity squared plus 2AD. The other one is final velocity equals initial velocity plus A times T. And then D equals initial velocity times time plus 1/2 AT squared. So those are the 3 ones that you'll be using to solve these problems. So once we have 3 values in a dimension, we can then use it in an equation and solve for something. So we need to use the y dimension. We can't mix dimensions. So we only can say in 1 dimension. So what equation has these variables along with time? Yeah. Very good. So we use the bottom equation and we can solve for time. So we have -1 meter equals 0 times t plus 1/2 -9 times t squared. That just goes away, it's just 0. 1/2 times 9.8 gives you 4.9. Divide both sides by 4.9. Does anybody have this? When we do 1 divided by 4.9, what did we get for that? 0.204 equals t squared. Square root both sides and solve for t. Okay. 0.45 seconds. So that's how long it's in the air for. That's true for both dimensions. So we could put time in for the y and for the x. So it traveled vertically for 0.45 seconds and horizontally for 0.45 seconds. So that's the answer for A. How long was in the air for? 0.45 seconds. Now I'm going to part B. With what horizontal velocity did the ball roll off the table? So we want to know initial velocity in the x dimension. Well, now we have 3 values. We can now solve for that. So we want to choose an equation that has these 3 variables that we know, along with the unknown initial velocity. So we would look and we can see that the equation we'd have to use would be d equals 1/2 at squared plus vi times t. So we plug in everything in the x dimension and solve for vi. Okay, 3 meters. No acceleration, that just goes away. So now the equation just becomes 3 equals vi times 0.45. Divide both sides by 0.45. And that gives us the initial velocity. We get 6.7 meters per second. So that goes in for the x dimension now. So that's for part B. Yeah.
So why, when you crossed out the half, 0 to b, why is it 0?
Oh, I was just saying that just becomes 0. When you do 0 times t, you just get 0. All right, so that's for B. And then for C, what is the vertical velocity of the ball just before it hits the ground? So we need to now find the final vertical velocity. So what we're looking for now is VF in the y dimension. So we need to find an equation that has the variables we know along with VF to solve for that. We could actually use either. There's two equations we could use. It doesn't matter. We could use either of them. We'll just use the VF squared equals VI squared plus 2AD. So we would just multiply 2 times negative 9.8 times 1. And that gives us VF squared equals 19.6 meters squared over seconds squared. Square root both sides. What do we get after we've done that? 4.4, good. We get 4.4 meters per second. And that is a downward movement. You know, it's moving downward. So it would be correct to put a negative in here because it is a downward movement towards the ground. Okay, so that's for part C. And then for the last part, for question D, horizontal velocity of the ball before it hits the ground. What would that be? We don't need an equation for that one. Yeah. Very good, 6.7. So it's just constant. Horizontal velocity does not change. So as long as there's no air resistance, it's a constant speed. So 6.7 for D. All good in that? Does that make sense, everybody? All right. 2 is very similar to 1, so we'll skip over that one. I'll have you do that one on your own. Let's go into number 3 and go through that one together. Okay, number 3, a tiger leaps from a 12-meter high rock with a speed of 4.5 meters per second. How far from the base of the rock will she land? So tiger, I don't even know how to draw a tiger. That's a really fat tiger. You guys use your imagination. So you don't have to draw it, but it helps to draw the situation, you know, see what's going on. But we know that rock is 12 meters high. The vertical speed, we would say is 0 vertically because she's going horizontally, which means there's no upward movement at all. So initial vertical velocity we'd say is 0, but horizontally she's going at 4.5 meters per second. How far from the base will she land? So they're asking the x distance. We want to know this distance right here. That's the x distance that she traveled. So it helps again to think about it in terms of x and y and write all the things we know in each dimension. So we always know acceleration in both dimensions, no matter what, as long as they're in the air, acceleration is 0 for the x dimension and 9.8 for the y dimension. We also know initial velocity in the x dimension. They give it to us. They say it's 4.5. And vertically, she's going straight horizontally, so there's no vertical movement. So initial velocity in the y dimension is 0. what else do we know? We know the distance horizontally, actually vertically, is 12 meters. And then horizontally, that's the unknown. So what we want is a answer in the x dimension, but we don't have three things known. Without three known variables, we cannot solve in the x dimension. But we do have three variables in the y dimension. So what we can do is use the three variables to solve for time, because time is the same for both dimensions. So if we know time in the y, we know time in the x. And once we get time, we now would have three known variables in the x. We could then solve for distance in the x. So in a case like this, where we have three variables known, but it's in the wrong dimension, we can use it to solve for time, and time is good for both dimensions. Then we can solve for our unknown that we need, which is distance. So let's look for an equation that has these three variables along with time. Oh, well, this is y and x, right? You know, so this is one dimension right here. Does that answer your question?
Yeah. How do you know if you need three or four to solve for the
Well, we always need three. So once we know three, we can solve. Now over here, though, we only have two known variables. We want the distance, but we don't have three, so we can't solve. But what we can do, though, because we know three in this dimension, is use those three to solve for time. Once we know time, well, that's the same in here and in here. Time is always the same in both dimensions. That would then give us now three known variables, which we could then use to solve for time or for distance. So we want to solve for time in the y dimension, which is the same as time in the x dimension, which we could then use then to solve for distance. So look for an equation that has these things. Distance equals 1/2 at squared plus vi times time. So the line is moving downward. So we would say it's -12 for a distance. And then 0 times t just gives you 0, so that just goes away. So our equation looks like this. 12 equals 1/2 times 9.8 times t squared. So that equation just becomes 12 equals -4.9 times t squared. Divide both sides by 4.9. Okay, so we now have -12. So meters canceled out up here. -12 over -4.9. The units right now is 1/t down there. What do we get when we do 12 divided by 4.9? 2.45. 2.45. The unit would be 1/1 time. Actually, I'm sorry, not s squared. Sorry about that. So that was actually s squared right there and right there. So our unit would be 1/1/s squared, which just is the same as s squared. So we now have 2.4 seconds squared equals t squared. square root both sides, and we get time. What does that give us? 1.5. Okay, so time is 1.5. And again, that's good for both dimensions. So we have 1.5 in the y and in the x dimension. So now that we know time in the x dimension, we now have 3 known variables. We can solve for what we need to know, which is the distance in the x dimension. So we can use the same equation that we used earlier to solve for the distance. So all I'm going to do really is just multiply 4.5 times 1.5. That gives us the distance that you traveled forward. Yeah, 6.8. So she went 6.8 meters forward. All right, any questions about those? All right, so go back and work on the rest of the problems we didn't do. The rest should be solved in a very similar way to what we did on the board.